Hello everyone and welcome to Krypton. Today we're going to talk about one of the most fascinating concepts in physics, Bernoulli's theorem. Named after the Swiss mathematician Daniel Bernoulli, this theorem helps us understand how the pressure of a fluid changes as it moves through different sections of a pipe or a channel. Whether you're interested in science, engineering, or just curious about the world around you, this is an idea that you don't want to miss. So let's dive in. First, let's define what we mean by a fluid. A fluid is a substance that can flow and take the shape of its container. Examples of fluids include liquids like water or oil, and gases like air or helium. When a fluid flows through a pipe or a channel, it experiences different forces that affect its behavior. One of these forces is pressure. Bernoulli's theorem states that the pressure of a fluid decreases as its velocity increases. This might seem counterintuitive at first. After all, we usually associate higher speeds with higher forces. But when we think about the fluid particles themselves, it starts to make sense. As a fluid moves faster, its particles collide more frequently and with greater energy. This leads to an increase in the overall kinetic energy of the fluid, which is proportional to its velocity. However, since the total energy of a fluid must be conserved, this increase in kinetic energy must come at the expense of other forms of energy, namely, pressure and potential energy. To see how Bernoulli's theorem works in practice, let's imagine a simple experiment. Suppose we have a horizontal pipe with two sections of different diameters, a wider section on the left and a narrower section on the right. We let a fluid flow through the pipe from left to right, and measure the pressure at several points along the way. According to Bernoulli's theorem, we should expect to see a lower pressure in the narrower section than in the wider section, since the fluid is moving faster there. This can be confirmed experimentally with a pressure gauge or a manometer. So, what are some real-world applications of Bernoulli's theorem? Well, there are many. One of the most important is in the design of aircraft wings. By shaping the wing so that the air flows faster over the top than the bottom, engineers can create a pressure difference that generates lift. This is what allows airplanes to stay in the air and perform all sorts of amazing maneuvers. Bernoulli's theorem also plays a role in the design of water treatment plants, where it's used to control the flow of water through various filters and pipes. It's also important in the field of fluid dynamics, where it's used to study everything from blood flow in the human body to the behavior of ocean currents. In conclusion, Bernoulli's theorem is a fascinating idea that helps us understand the behavior of fluids in motion.